Hello there, and welcome back to the Sleep Science. You're lying on your back, probably. The ceiling above you fades into the soft hush of the dark, maybe flickering faintly with the blue glow of a phone charging beside you. But close your eyes a little more and picture this instead. A black sky peppered with stars that aren't just dots. They're holes punched in a great dome above the world, letting in light from some brighter heaven beyond. You're lying not on a mattress, but on the flat, unmoving disk of Earth. Around you is the endless ocean. Above, the sky curves down like an overturned bowl. And beyond that, you don't want to know. This, for thousands of years, was reality. A dome, a disk, a divine egg. Neat, closed, comforting, and almost certainly wrong. You probably won't survive this. So, before you get comfortable, take a moment to like the video and subscribe, but only if you genuinely enjoy what I do here. And hey, drop your location and local time in the comments. I always like seeing where in the world you're falling asleep. Now dim the lights, maybe turn on a fan for that soft background hum, and let's ease into tonight's journey together. You're in Mesopotamia now, or maybe it's Egypt, or some misty overlap of both, because truthfully, nobody drew clear borders back then, especially not in the cosmos. The sky above you is no longer emptiness. It's a person, a structure, a living vault. The Babylonians imagined a firm, metallic sky, hammered out by the gods like a bronze lid. Rain fell through little holes. The stars moved along fixed tracks, obedient like insects on invisible strings. In ancient Egypt, the goddess Nut arches her body over the earth, feet in the west, fingertips in the east. The god Geb lies beneath her, skin covered in green shoots and rivers. Every night, Nut swallows the sun, and every morning she births it again. Probably not the most comfortable cycle, but hey, divine work is rarely ergonomic. Your reality here isn't made of atoms or quarks. It's made of story, myth, and metaphor. And honestly, that's a kind of geometry too. Historians still argue whether these myths were meant literally or poetically. Was the dome believed to be real metal, or just a convenient symbol? But that uncertainty doesn't make the model any less important. You live in a dome when you act like it's a dome. And when the stars behave in predictable ways across your sky, you start building calendars. You plant, you harvest, you survive. Whatever the cosmos is really shaped like doesn't matter yet, it works. Meanwhile, over in India, things are getting eggy. The Brahmanda, or cosmic egg, is the primordial container of everything. The universe nested like a yolk in a shell, floating in a sea of eternal potential. And once it cracks, boom, time, space, gods, you, everything. Your entire reality hatches, which feels appropriately messy. But the egg isn't unique. The Finns had a duck's egg version. The Chinese myth of Pangu imagined the cosmos emerging from a cracked egg, too. Half became the sky, the other half the earth. One wonders what ancient cosmologists had against omelets. And speaking of cosmic poultry, let's drift up to the Norse vision for a moment. Reality begins as Ginnungagap, the yawning nothingness between fire and ice, from which emerges Ymir, the first being. Once Ymir dies, spoiler, his body becomes the structure of the world, flesh as earth, skull as sky. Yes, you are now technically living inside the decapitated head of a frost giant. Don't think too hard about it. If you're still holding onto modern scientific instincts, try not to laugh. The ancients weren't trying to be silly. These were serious, rigorous attempts to answer the deepest human question. What the heck is this place? And if it takes a giant cow licking creation into existence, or a deity hammering the sky into shape, so be it. There's even an old Hebrew idea in Genesis that God separates the waters above from the waters below using a firmament, a solid sky roof holding back an ocean. Think of it as early waterproofing, because when the great flood comes, that roof cracks wide open. And yet in all these early views, the world is enclosed. It has shape, boundary, purpose. You live inside a cosmos with walls. Even the underworld is beneath you, an actual layer, not a metaphysical idea. There's nothing abstract about it. Dying is just spatial relocation. And so you sleep under a sky that's not space but ceiling. The moon isn't a rock, it's a lamp. The stars aren't suns, they're pinholes or glowing points moved by divine gears. And reality in this context feels intimate. Terrifying maybe, but comprehensible. Here's the quirky part. Some Australian Aboriginal groups believe the sky was a land of its own. Not a dome, but a literal place. A mirrored earth. You die and you walk upside down among the stars. Ancestors wander that reversed landscape. Your reality isn't lost, it just changes hemispheres. Of course, none of this is scientific in the modern sense, but let's not get too smug. These weren't lazy guesses, they were experiential, observational. People stared at the heavens every night without light pollution or tick-tock. Patterns emerged, cycles repeated, and where there's pattern, there's shape. You know how you sometimes stare at your ceiling and start seeing faces in the paint? That same instinct created constellations. Orion with his belt, the Scorpion, the Big Dipper. That need to find structure, to impose story. And over centuries, those stories became cosmologies. They mapped not just the sky, but your place in it. And so here you are, drifting in a reality shaped like a dome or an egg or a giant skull. You can touch the stars if you climb high enough. If you fly too far, you'll hit the edge, or fall off, or meet the gods. Whatever the truth is, it's shaped like something you can imagine, something you can stand under, something with edges. That's the trick of ancient reality. It always has a ceiling. You wake up flat on your back again, but this time it's warm soil under you, not your mattress. The stars are different. The air smells like smoke and moss and stories told by firelight. You're older than cities now, or maybe just younger than history. Because where you are, somewhere deep in the ancient forests of pre-literate Earth, the shape of reality is more vertical than spherical. Not a dome, not an egg, but a tree. You look up, way up, and there it is, Yggdrasil, or the world tree, or whatever your local tradition happens to call it. Because versions of this reality pillar show up everywhere. Norse sagas, Siberian shamanism, Mayan mythology, even old South American stories told in vine-twined temples. A cosmic axis, Axis Mundi, stretching roots into the underworld and branches into the heavens. The entire universe stacked like floors in a cosmic apartment building. In this model, you don't fall off the Earth's edge. You fall through its levels. From Midgard to Niflheim to Asgard. From mortal muck to divine halls. If the dome of the sky gave you a ceiling, the world tree gives you an elevator shaft. And every realm on the way up or down is real. The Mayans had 9 levels of the underworld, each guarded by scary, often grumpy gods. The Hopi people described 3 worlds below and 3 above. In some Hindu cosmologies, there are 14 worlds stacked like pancakes, 7 above, 7 below. Earth is just one lonely pancake in the middle, probably with a bit too much syrup on it. And yes, the famous turtles all the way down model. That fits right here too. You've probably heard it as a joke, a kind of philosophical zinger. But it was once a serious cosmological vision. A flat Earth resting on the back of a giant turtle, which stands on another turtle, which stands on another, and so on forever. A vertical infinity. Historians still argue whether the infinite turtle story originated in Hindu cosmology, Native American myth, or was a later mashup invented by colonial-era philosophers trying to simplify silly native beliefs. Either way, the stack remains one of the most enduring and quietly hilarious ways humans have tried to picture what holds everything up. The important thing here isn't the turtle, it's the instinct to build downward. When you ask, what's beneath this? You get a tree, or a series of realms, or a divine reptile platform. Whatever your culture, you instinctively give reality some scaffolding. Even in ancient China, you'd find a mountain at the center of everything, Mount Kunlun, a mythic peak where gods dwell and rivers originate. It's like Earth's own spinal cord. Reality always needs a middle. But let's go weirder. In the Dogon traditions of Mali, the universe begins not with a dome or tree, but a spiral, a cosmic vibration. Reality spirals out from a single point, the same way a snail's shell grows. Their myth includes twin creators, one of whom rebels and causes disorder, which feels suspiciously like ancient string theory with family drama. You're beginning to sense a pattern, aren't you? These aren't just stories, they're geometries. Early models of reality weren't abstract. They were symbolic blueprints that explained motion, weather, birth, death, and everything in between. You didn't need a telescope. You needed a story with the right shape. Let's visit Mesopotamia again briefly. Here, the Earth is a flat disk surrounded by a cosmic ocean. The heavens are tiered above, the underworld tiered below. It's all floating in water, salt water to be exact. Enlil, the air god, separates sky and earth. Enki, the god of freshwater, lives below. You are effectively a sandwich between elements. The universe has layers, but it also has moisture. Delicious. Quirky side note. In Maori mythology, the Earth Mother Papatuanuku and Sky Father Ranginui are locked in a tight embrace. Their children, cramped in the darkness between their bodies, eventually push them apart, creating space, light, and a bit of healthy family tension. So in this version, reality isn't built, it's pried open. Let's also give a nod to the Inca. Their cosmos, divided into 3 levels, the upper world Hanan Pacha, this world K Pacha, and the underworld Uku Pacha. Each is connected by symbolic animals, the condor, the puma, and the serpent. Once again, shape becomes metaphor. If the world feels disordered, maybe you're just stuck in the wrong layer, or talking to the wrong animal. And it's not just shape, it's function. These models often mapped onto real things: seasons, eclipses, fertility cycles, rainfall. If your crops failed, it wasn't bad luck, it was bad balance. A misaligned layer, a kink in the tree. By now, your modern brain may be itching for equations, diagrams, at least some basic gravitational mechanics. But slow down. These layered cosmologies are doing something we still try to do: tame the chaos. Give the infinite some levels. Put the terrifying unknown into an organizational chart. And funny enough, we still talk like this. High spirits, low places, rock bottom, cloud 9. The language of stacked worlds has never really left you. It just got dressed up in metaphor and psychology. Your soul may not ride turtles anymore, but it definitely has its ups and downs. Here's the strange thing. These vertical or stacked universes, despite being mythological, are often more emotionally useful than modern physics. In those ancient stories, there's always somewhere else to go, a deeper level to descend into, a higher one to strive for. Space isn't cold, it's full of meaning. So you lie here under an ancient sky, feeling the slow pulse of the world tree above you and below. You are inside a structure made of meaning. You're not adrift in space, you're lodged in a cosmic framework, which is comforting until you remember the elevator might be going both ways. And if you dream of climbing higher, beware. Gods live up there, and gods are notoriously weird landlords. You open your eyes again, this time to columns, sunlight, and marble that hums slightly beneath your feet. You're in ancient Greece now, somewhere between philosophy and obsession. The air smells of olive oil, sun-warmed limestone, and just a hint of egotism. Because the Greeks, they want answers, not just stories. They want geometry. Reality here has shape, sure, but it also has symmetry, ratios, logic. If earlier cosmologies were mythic blueprints, this is where they start looking like math homework. And you're about to sit cross-legged on the floor beside Pythagoras, who's explaining why the entire universe might be vibrating in musical harmony. You're going to pretend to understand him. Good luck with that. The first thing you notice is how much these guys trust in numbers, not just as counting tools, but as universal truth machines. For Pythagoras and his followers, yes, they were basically a math cult. Reality is built from perfect forms. The triangle, the square, the circle, the platonic solids. Everything you touch, see, or are is made from number. Historians still argue whether Pythagoras actually came up with the theorem named after him, or just made it famous while walking barefoot around southern Italy, refusing to eat beans. But what's clear is that he, and later, Plato, introduced the seductive idea that the world isn't messy at its core. It's elegant, clean, geometric. Plato in particular was a sucker for shapes. He believed the four classical elements, earth, water, air, and fire, were each built from a different Platonic solid. Earth is made of cubes because cubes are stable. Fire, tetrahedrons, sharp, pointy, dangerous. Air is octahedrons, water, cosahedrons, and the fifth shape, the dodecahedron. That's the shape of the heavens, because of course it is. Imagine that, the entire cosmos encased in a divine 12-faced dice. It's either a divine architecture or a very complicated board game. You walk through Athens hearing phrases like harmony of the spheres. The heavens aren't just pretty, they're playing music. You just can't hear it because it's constant, like cosmic tinnitus. Pythagoras believed the planets and their movements created a kind of celestial soundtrack, ratios of motion corresponding to musical intervals. Reality, quite literally, vibes. Of course, nobody had telescopes, but the Greeks had eyeballs, math, and more than a little arrogance. So when they looked up and saw the stars moving predictably, they didn't just map them, they deduced what must be holding them. Geometry wasn't just useful, it was truth. Sensory reality was a pale copy of ideal forms. You lived in the shadows, friend. The real world, that was math. And yet, not all was unified. Even then, thinkers disagreed wildly. Anaximander believed the earth floated in space like a drum, unsupported by anything. Heraclitus thought reality was constant flux, fire consuming itself. Zeno tied people in logical knots about motion and distance. They were throwing ideas like darts at the walls of the cosmos. There's a quirky theory that ancient Greek temples weren't just religious, they were built to align with certain celestial events, solstices, star risings, which means even sacred architecture was treated like a cosmological diagram, every building an argument about the universe's shape. By the time you get to Aristotle, things start to firm up. He combines the best myths with the best geometry and gives you a universe that finally feels stable. Earth in the center, planets orbiting in perfect circles, spheres upon spheres, each one made of an incorruptible substance called ether. It's like nesting dolls, but celestial. He divides the cosmos into two regions, the sublunar, everything under the moon, subject to change and decay, and the superlunar, everything beyond the moon, perfect, eternal, and unchanging. This is where science and storytelling finally shake hands. Aristotle's model isn't spiritual metaphor, it's a full-blown physical model. Testable, tweakable, wrong, but impressively sticky. Historians still argue whether Aristotle's layered spheres were purely philosophical, or whether he genuinely believed in literal crystal balls rotating above Earth. Either way, his model lasted nearly 2,000 years, which is longer than most empires, phones, or refrigerator warranties. There's something almost comforting about it. Earth isn't just at the center of the universe, it's encased in harmony, protected by layers, held in cosmic geometry. The outermost sphere, the primum mobile, turns everything else. It's moved by the unmoved mover, which Aristotle names as the ultimate cause, kind of like pulling back from physics into metaphysics at the very end. Just when you thought you had it figured out, boom, mystery. Fast forward a few centuries and enter Claudius Ptolemy, hanging out in Alexandria around 150 CE. He inherits Aristotle's model and makes it extra. He adds epicycles, circles upon circles, to account for the wobbly movements of planets in the sky. Mars moving backward, no problem, just add another loop. You feel dizzy just looking at it, but you can't deny it works. The math predicts eclipses. It maps Venus. You can print calendars with it. If reality looks like this many gears, maybe it is this many gears. Of course, it's completely wrong. But here's the beautiful lie. It was usefully wrong. And that's the twist, isn't it? The Greeks didn't build the perfect model, but they built the idea that there should be one. That reality has a shape, and that shape can be described, measured, understood, and eventually questioned. Because once you believe the cosmos has rules, you also believe those rules might be improved. So you walk the white marble streets of Athens again, mind humming with angles and ratios. You squint at the stars, and instead of gods or eggs or cosmic cows, you see circles, numbers, perfection hiding behind imperfection. And maybe, just maybe, you hear a tiny bit of music too. You blink and the marble dissolves beneath you. Now it's brass and parchment, flickering oil lamps, and a sky that moves in clockwork loops. You're perched in the Hellenistic world's long echo, maybe in Alexandria again, or Constantinople or Baghdad. The world hasn't changed shape exactly, but it started spinning a bit more smoothly. You are now inside a universe of spheres, many, many spheres, each turning with precise, almost smug regularity. Aristotle's model, remember. Earth at the center, celestial bodies glued to transparent rotating spheres. Ptolemy made that model sing. He added extra circles, epicycles, to make the math work. And for centuries, this Baroque machine was reality. No one could see it, but you could feel its gears turning every time Venus appeared where she should, or the moon eclipsed just on schedule. You look up at the sky and you don't see randomness. You see a giant timepiece, and not just metaphorically. In the 2nd century BCE, someone built the Antikythera mechanism, a real physical computing device made of gears that modeled the movements of heavenly bodies. It was recovered from a shipwreck, encrusted with salt and secrets, a bronze brain designed to mirror the sky. Historians still argue whether it was a one-off masterpiece or part of a larger Hellenistic tradition of analog computing. Either way, it proves something weird and wonderful. People weren't just imagining reality's shape. They were trying to build it, shrink it, pocket it. Reality became not just a story or diagram, but something mechanical, something you could rewind. You sit in a quiet room as scholars from many lands, Greek, Persian, Arab, debate how many spheres exist. Some say 7, some say 9, some go higher. Each planet has its own shell, its own velocity, its own music. Above them all spins the fixed stars, like sequins stitched to the final veil of heaven. Above that, the prime mover, God maybe, or whatever turns the first gear. You're probably wondering where the sun fits in all this. Well, here, where things get a little more twisted than tidy. In Ptolemy's model, the sun orbits Earth just like the moon and the planets. But to make that math work, he adds extra circles upon circles, each one explaining a slight wobble or deviation. Mars moving backwards, epicycle. Jupiter's brightness changing, epicycle. It's like cosmic patchwork. And yet it works. It matches observation. For 1,400 years, this system guides calendars, tides, agriculture, and astrology. It's so ingrained that questioning it feels like heresy, and eventually it is. But let's pause here. You're still in a world where everything above the moon is perfect, eternal, and unchanging. Below the moon, that's your messy zone. Things fall, decay, die. But up there, that's God country. The stars move with absolute precision, and therefore they must be divine. The sky isn't space, it's order. And Earth? Well, Earth is just sitting here, lumpy and imperfect, in the middle of all that rotating majesty like a cosmic couch potato. A quirky fact for you. Medieval scholars debated whether the celestial spheres were made of crystal or some other transparent, indestructible substance. They even tried to calculate their thickness. Some believed these spheres made literal music, what we now call the music of the spheres. Others said the music was spiritual, inaudible to humans dulled by sin or too many bad harvests. There were attempts to explain why comets appeared to cut across multiple spheres, seemingly ruining the whole perfect shell idea. Maybe they weren't in the heavens at all, some said, just atmospheric disturbances. Others got nervous, because a tear in the outer shell, that wasn't just a scientific problem, it was an existential one. If heaven could be punctured, maybe it wasn't heaven at all. Still, the system held. It had elegance, and more importantly, it had authority. And speaking of authority, here come the Church Fathers. By the Middle Ages, the model is fully enshrined not just as science but as theology. The outermost sphere isn't just where God kicks back with a lemonade. It is the divine realm. Dante, in his Divine Comedy, describes passing through each of the planetary spheres, each one corresponding to a virtue or a sin. The structure of the cosmos becomes a moral ladder. And Earth, it's at the center not because it's special, but because it's heavy. Lo, the least perfect. You are not the crown of creation, you're the basement, which, let's be honest, feels about right some days. Still, there's an odd kind of comfort in this crystalline model. Everything has a place. Everything moves for a reason. Even if the system is wrong, and spoiler, it is, it offers something deeply human, structure. You could map your soul using this sky. You could time your prayers to the movement of Venus. You could chart your fate in the curvature of a turning sphere. There's also this. Medieval Islamic astronomers, particularly those in Persia and Andalusia, took the Ptolemaic system and tried to fix it. Not abandon it, perfect it. They added refinements, new tables, better observational instruments. They even proposed models where the equants, those weird little orbital cheat points Ptolemy used, were eliminated, because even error must be elegant. Historians still argue whether Copernicus drew inspiration directly from these Islamic models, or whether his heliocentric leap came independently. But the record is clear. Long before the Renaissance claimed science, it was humming quietly in Arabic, Hebrew, and Farsi. But you're still here, lying on your back beneath a sky that isn't just above you, it's wrapped around you. You live in a sphere, nested in other spheres, ticking with divine precision. The stars don't twinkle, they rotate. The cosmos doesn't expand, it turns. It's not until someone dares to say, "What if we're not the center?" that this glorious machine starts to fall apart. But for now, it's night. The spheres spin, the stars sing, and you're right where you belong in the eye of a very confident illusion. You blink and the gears grind to a halt. The crystalline spheres shatter silently, dissolving into cold night sky. There's a breeze now, salty, impatient. You're standing on the deck of a ship somewhere off the coast of Portugal, staring at a compass that twitches like it's keeping secrets. Below you, the earth, curved, unmistakably curved. Reality just got sea legs. Maps are changing in your hands, not metaphorically, literally. Cartographers are redrawing coastlines, repositioning continents, and suddenly realizing that dragons are not a viable navigational aid. Welcome to the era where reality's shape has to fit on a page. You roll up a mappamundi, one of those medieval maps with Jerusalem at the center and Eden somewhere near the top. These aren't designed for travel. They're devotional, symbolic. The world laid out like a prayer. East is up, paradise glows, and somewhere at the edges, monstrous races with dog heads and backwards feet. You know, the usual. But then the Renaissance hits, and people start demanding accuracy over allegory. Mercator, your new favorite Flemish map nerd, publishes a projection in 1569 that revolutionizes how we visualize Earth. His map is rectangular, grid-lined, and very wrong in one crucial way. It distorts size. Greenland looks enormous. Africa shrinks. But suddenly, sailors can chart courses with straight lines. Navigation trumps truth. Historians still argue whether Mercator deliberately warped geography to favor colonial powers or simply made a mathematical compromise. Either way, the shape of the world just became a political document. And with that shift comes something else, doubt. Because the more you measure, the more you realize the old models don't quite fit. You sail west expecting monsters and hit the Bahamas instead. You head south of the equator and discover new constellations, unfamiliar stars. That tidy, layered sky of Aristotle, it's looking suspiciously full of holes. Even the North Star won't stay still. Depending on where you are, it wanders. The sky is regional now, which means your place in the cosmos isn't universal, it's positional. You exist in a context. Let's go further back for a moment. The Greeks, particularly Eratosthenes, had already calculated the Earth's circumference with shocking accuracy in the 3rd century BCE, using shadows and a well in scene. But that knowledge wasn't exactly common property. Much of it got misquoted, forgotten, or politely ignored in favor of more spiritually satisfying models. But by the 15th and 16th centuries, those measurements become crucial. Reality, it turns out, needs to be accurate. If your map is off, your ship goes down. Or worse, you arrive in someone else's empire and accidentally start a war. So here you are, fingers ink-stained, squinting at a globe that didn't even exist a century earlier. Martin Behaim builds the Earth Apple in 1492, the oldest surviving terrestrial globe. It's wildly inaccurate but visually revolutionary. The world is now round, not because everyone suddenly believed it, but because they could now see it that way. And here's the thing, round Earth wasn't new. Scholars had argued for it since antiquity, but now it's more than theory, it's tool. You don't just believe in a spherical Earth, you use it, you measure it, you sail by it. Quirky detour. Did you know that in the 12th century, Islamic scholars created astrolabes so precise they could calculate the Qibla, direction of prayer, down to fractions of a degree? These weren't gadgets. They were devotional tech, maps of meaning layered onto physical space. But not everyone's thrilled by this transition, because once you flatten the Earth onto a chart, you also flatten worldviews. Land becomes resource, territory becomes target, the map becomes a weapon. And yet there's a strange beauty in this unfolding. You're not just imagining the cosmos anymore, you're interacting with it. You can't touch the stars, but you can triangulate them. You can't visit the edge of the world, but you can finally say, there isn't one. Reality's shape begins to shift from layered to gridded. It becomes something you can fold, carry, argue about. Every cartographer makes choices. Center this, enlarge that, distort those coastlines to fit a rectangle. The act of mapping isn't neutral, it's a declaration. Take the T and O maps from the early Middle Ages. A circle divided into a T, Asia on top, Europe and Africa below, Jerusalem right in the middle. It's not geography, it's worldview. The shape of the map is the shape of belief. Then Mercator's projection comes in like a spreadsheet. Latitude and longitude, straight lines, navigable angles. And yes, it lies, but it lies consistently, which, if you think about it, is half of science. Historians still argue about the ethics of map distortion. Should you prioritize shape, size, cultural neutrality? The Peters projection famously restored relative landmass size but made continents look like they'd been ironed. The Robinson projection tried to split the difference. But the truth is, no flat map can perfectly represent a round planet. The shape of reality is uncooperative. And that's the deeper truth you're starting to feel here. The more accurately you try to depict reality, the more compromises you have to make. You can have truth or you can have utility, rarely both. But for now, you're standing in the age of explorers and navigators, globes and grids. You've left behind the fixed stars and crystalline spheres. Reality is now curved but comprehensible, tangible, mappable. And yet, you haven't looked up in a while, have you? Because just as you're figuring out the shape of the Earth, someone's about to suggest that it isn't even at the center. And that little shift, that's going to crack open everything you thought you knew. The sky is different tonight, not just in shape but in mood. It feels colder, more distant, like it knows something you don't. You're standing beside a quiet man named Nicolaus Copernicus, and he's been staring at the heavens a little too long. He doesn't say much, but when he does, the words shift the floor under your feet. What if the Earth moves? You blink, surely not. Everything you've been told, everything everyone's been told, says Earth is still. Central, the sky moves around us. That's how things are, that's how they've always been. Right. And yet Copernicus places the sun at the center of everything, and suddenly you're no longer the cosmic VIP. You're orbiting, you're moving, you're spinning at hundreds of miles per hour, flung through space like a speck on a carousel. Your reality is now mobile and a little nauseating. But here's the quiet genius of it. Copernicus doesn't smash the old system, he tweaks it. He keeps the circular orbits, the nested structure, the old-school elegance. He just shifts the center, one simple change, and suddenly everything else has to bend. Historians still argue whether Copernicus truly believed in the physical truth of his model, or simply offered it as a better mathematical tool. His De Revolutionibus Orbium Celestium was published in 1543, the year of his death, possibly to avoid the awkward social side effects of implying that everyone else had been wrong for 1,500 years. And make no mistake, this wasn't a popular opinion. You don't just say the Earth moves in a society built on geocentrism and expect to get high fives. Even Martin Luther, always eager to pick a fight, called Copernicus a fool who wants to reverse the entire science of astronomy. But Copernicus lights the match, others fan the flame. Like Tycho Brahe, a Danish nobleman with a brass nose, an elk that drank too much, and a talent for detailed observation, he proposes a geoheliocentric model, basically a compromise. The planets orbit the sun, but the sun still orbits Earth. A cosmic loophole, because progress, apparently, involves a little backpedaling. Then comes Johannes Kepler, Brahe's apprentice, who takes all that glorious observational data and does something outrageous. He breaks the circle. He replaces it with the ellipse. That's right, orbits aren't perfect circles. They're squished, imperfect, and yet more accurate. Kepler's 3 laws of planetary motion describe a solar system that's mathematical, predictable, and kind of ugly. Reality, it turns out, doesn't care about aesthetic purity. You feel that shift in your bones. The universe no longer cares about elegance. It just works. And working means sacrificing beauty for accuracy. If the planets move in ellipses, then so be it. You either accept the weirdness or you fall behind. Now come the telescopes. Galileo Galilei turns his spyglass toward the night and finds moons orbiting Jupiter, craters on the moon, sunspots, imperfections in the supposedly perfect heavens, the celestial spheres, gone, the stars, infinite, the Earth, just another moving speck in a vast, possibly endless void. He publishes his findings. He mocks old ideas. He pokes the bear. And the bear in this case is the church. Historians still argue whether Galileo's trial was about science, politics, or just a stubborn old man getting under the skin of equally stubborn officials. But in 1633, he's found vehemently suspect of heresy and placed under house arrest. He's told to recant, to say Earth doesn't move. He does, and then allegedly mutters under his breath, "E per se muove," and yet it moves. Meanwhile, reality doesn't care. The universe has changed shape again, and this time it's not a static diagram, it's dynamic. Everything spins, orbits, falls, and flies. You're not at the center. You're not even stable. You're a traveler clinging to a rock that hurtles through space with no top, bottom, or cosmic floor beneath your feet. And here's the wild part. The more you move away from the old Earth-centered view, the more the sky grows. No longer a fixed dome or a series of nested shells, it becomes deep, dark, and full of stars that aren't holes in anything. They're suns. Distant, burning, lonely. Which raises a terrible question. If they're suns, then where are the other Earths? You can feel the early tremors of existential dread. Because if reality is heliocentric, maybe even galactocentric, then your place in it is shrinking. And with each new discovery, that place grows less privileged, less protected. You're not the center of anything. You're not even close. But there's a strange thrill in that too. The cosmos is opening. The map is expanding. Quirky side fact. Before telescopes, people argued that the stars must all be painted on the same sphere because they never changed positions. After telescopes, some begin to suspect the stars are other suns, unimaginably far away, and the dark between them, not canvas but distance. And so you float here, spinning gently on your heliocentric marble, watching the universe inflate around you. The clockwork model of old, gone, the perfect orbits, smeared, the crystalline heavens, dust. but in their place motion, pattern, predictable madness. You now live in a reality shaped not by myth or moral order, but by math, by physics. And for the first time, you realize that truth may not feel satisfying. It may feel cold, disorienting, but it explains things the old stories couldn't. Like why Mars loops in the sky, or why Venus has phases, or why gravity isn't a force pulling things down, it's pulling things in. You're not just watching the cosmos anymore, you're inside it, and it's not built around you. You orbit now, get used to it. You're in a garden now, the kind of garden that smells of apples, ink, and quiet revolution. There's a man here, not young, not especially tidy, sitting under a tree with a head full of calculus and a mind that refuses to stay put. His name is Isaac Newton, and he's about to do something wildly irresponsible: mathematize the universe. The story goes like this. An apple falls on his head. Cute, right? Except the story is almost certainly exaggerated, or fabricated, or metaphorical, or maybe just a great piece of 17th century PR. Historians still argue whether Newton ever sat under that apple tree or whether someone else just made it up to simplify a mind too complex to summarize in fruit metaphors. Either way, you're here now and you're watching something new, reality becoming law. Because Newton doesn't just describe gravity, he defines it. He gives it rules. He writes down 3 laws of motion so tidy, so terrifyingly elegant, that suddenly everything from cannonballs to comets can be plotted, predicted, understood. The Earth orbits the Sun not because of divine music or mysterious tendencies, but because of a quantifiable force. A force that works everywhere. And for the first time, you're no longer dealing with a local cosmos. Newton's laws apply to the heavens and the Earth. No more sublunar corruption versus superlunar perfection. It's all one machine, one system. The same gravity that pulls the apple down is the same that keeps the moon from wandering off. You don't live inside a cosmic diagram anymore. You live inside a clock, a perfect, precise ticking machine. The universe is now mechanical, predictable, obedient. And you're not at the center, but at least you can calculate your insignificance. There's a beautiful cruelty to Newton's model. It explains so much. Elliptical orbits, sure. Tides, easy. Planetary motion, bring it on. But it also removes the poetry. The cosmos no longer sings, it ticks. Reality is a grid. Space is flat. Time flows evenly like a universal conveyor belt. Newton even defines space itself. Absolute, immovable, unchanging. A great invisible stage upon which all events unfold. And time, same deal. Constant, linear, universal. Reality's shape in Newtonian terms is like a massive, empty box with everything moving predictably inside it. But then he makes a weird choice. He brings God back in, not as a deity who micromanages, but as the initial clockmaker, the divine watchmaker. God winds up the machine and steps back. No tinkering, no angels pushing planets, just pure mechanics. Quirky side note. Newton was deeply obsessed with alchemy and biblical prophecy. He spent more time trying to decode scripture and turn lead into gold than he did on optics or motion. But history, in its usual irony, remembers him for the parts he kept tidy. Still, the shape of reality now feels stable, maybe too stable. You move through space like a billiard ball. You exist on a cosmic grid where every action has an equal and opposite reaction. It's reassuring, and also a little cold. But oh, the predictive power. You can launch cannonballs and know where they'll land. You can chart the moon's phases centuries in advance. You can predict eclipses, tides, even the wobbles of Saturn. Newtonian mechanics doesn't just describe the cosmos, it controls it. Or at least, it lets you pretend. And in this model, reality becomes a kind of divine spreadsheet. A place where everything can be tallied, tracked, computed. It's the birth of classical physics and the death of mystery, at least temporarily. You imagine the cosmos as a vast sea of particles bouncing around under strict supervision. No exceptions, no surprises, cause and effect neat and tidy. And that's the twist. Because you start to realize how much control this gives you. If you know the forces and the masses and the distances, you can predict everything. The past, the future, all of it becomes solvable. Laplace, a later mathematician, famously suggests that if you knew the position and momentum of every particle in the universe, you could predict the entire future. No free will, just physics. Reality in this sense has a shape, but it's fixed. No squishiness, no divine intervention, just a machine grinding forward in perfect precision. It's beautiful, it's terrifying, it's very, very efficient. But it also starts to feel limited. Because even as Newton's equations describe planetary orbits to jaw-dropping accuracy, they stumble in places. Mercury's orbit, for instance, doesn't quite behave. Light, too, acts weirdly. And this notion of absolute space, this great invisible grid, starts to feel less like a truth and more like a convenient myth. Historians still argue whether Newton anticipated the breakdown of his own system, or whether he believed he'd discovered a complete truth. But cracks are beginning to show. Subtle at first, like a tick in the gears of a clock that's been wound too tight. Still, for over 2 centuries, this model reigns. The Newtonian cosmos isn't comforting in the old mythic sense, but it gives you power, knowledge, prediction. And in a way, that's its own kind of religion. You now live in a universe of forces. You are acted upon. You act in return. You exist as a node in a vast mechanical grid of push and pull. There's no room for chaos here, only ignorance. And that, perhaps, is the most seductive illusion of all. But whisper it with me now, the universe isn't a clock, not really. It's stranger than that, looser, warped. It's about to bend in ways Newton's neat little math never saw coming. So enjoy this moment of certainty. The gears are turning, but they won't hold forever. Because just beyond the horizon, someone is watching light misbehave. And he's got questions. You wake up inside a fog, a quiet, humming, mathematically unsettling fog. And no, this isn't just the early morning haze of too little sleep, it's something deeper, thicker. The kind of fog that clouds not your vision but your understanding. And standing right in the middle of it, glasses slipping down his nose, is Immanuel Kant. He doesn't wave. He doesn't smile. He just hands you a question like a riddle wrapped in a whisper. What if space and time are not things, but ways you think? That's it, that's the vibe now. Kant isn't here to explain the shape of the universe. He's here to tell you the terrifying news that maybe there isn't a shape, not one you can ever know anyway. Because reality, he says, isn't just out there. It's filtered, warped, not by gravity or mass, but by you. You sit down slowly, not because you're tired, but because the floor might not be real in the way you thought. Here's the idea in soft Kantian tones. Everything you perceive, space, time, causality, is processed by your mind through built-in mental software. Space isn't a thing you discover. It's a structure your brain uses to organize experience. Time isn't flowing out there. It's the way your mind sequences events. Historians still argue whether Kant, transcendental idealism, is a profound insight or just philosophical gymnastics. But the effect is undeniable. He's torn a hole in the Newtonian backdrop. That big, clean, absolute stage where apples fall and planets dance. It might be nothing more than a mental stage prop. And that's a lot to take in, so let's pause, breathe. Imagine looking at the world through tinted glasses. You see everything, but the color is altered subtly, pervasively. You can't take the glasses off. You've had them on since birth. For Kant, that's what your senses and reason do to reality. You don't see the thing in itself, the real world behind the veil. You see the phenomenon, the version your brain can handle. And here's the wild part. This means science doesn't reveal reality. It reveals how you structure it. Measurement, observation, even perception itself are trapped inside this mental bubble. The universe you interact with is already prepackaged in human-friendly formatting. The shape of reality, it may exist, but it's behind glass, frosted, soundproof glass. You want an example? Try this. A bat experiences the world through echolocation. Its reality is shaped by echoes, not colors or edges. A mantis shrimp sees colors we can't imagine. A dog lives in a universe of smells. So which version is real? The Kantian answer: maybe all of them, maybe none. You live in a world defined by the shape of your cognition. Your reality is what's out there. It's what your brain can handle, which, let's be honest, might not be much. And now that doubt has been introduced, the gears of certainty begin to slip. Newton's laws still work beautifully, but they're working inside a user interface. You aren't in the universe, you're in the app. Quirky twist: Kant wasn't trying to destroy science. He loved Newton. He wanted to protect science by showing how it worked within the limits of reason. But in doing so, he handed you an uncomfortable gift: the realization that objectivity might be a very polite illusion. You wander the halls of thought now like a philosopher with a migraine, because once you start questioning the tools of perception, you can't stop. Is causality real, or just a useful habit of thought? Is time a flowing river, or just a sequence of neural firings? You remember that dream you had where time felt stretched, looped, or non-existent. You remember how sometimes 5 minutes feel like hours, and sometimes whole days vanish. That wasn't just mood. That was your mental clock revealing its fragility. Even modern neuroscience, armed with fMRIs and electro-whatever machines, shows that your sense of now is assembled post hoc, from scattered fragments. Your present moment is like a highlight reel, spliced together and fed to your consciousness with a slight delay. Reality, it seems, is lagging. Historians still argue how much Kant anticipated the psychological sciences of the future. He never saw a neuron, but he knew that what you see is not what is. And for that, philosophers either adore him or avoid him like a party guest who insists on bringing up metaphysics during dinner. Let's spin it another way. Kant didn't break reality. He just reminded you that all your models, even the most rigorous, are human-made. Space, time, motion, they may exist out there, but you only access them in here through a filter you can't shut off. And that changes everything. Suddenly, the shape of reality isn't just a matter of astronomy or physics, it's psychology, biology, evolution. What traits helped your ancestors survive? Seeing sharp edges, recognizing faces, judging distances. Your reality is biased toward usefulness, not truth. You walk through a world designed by your brain for your survival, not for cosmic accuracy. And in that fog of mental architecture, you realize something chilling and beautiful. Maybe every model of reality so far, from domes to spheres to Newtonian clocks, was never wrong. They were contextual, built for specific needs at specific times by specific minds. So what's next? You feel a subtle shifting under your feet. Newton's floor, flat, absolute, unwavering, begins to bend. Space will no longer be a passive container. Time will stop being a river. The gears will melt, light will curve, and your comfortable illusion of stability will go with it. But before we get there, sit for a moment with Kant. In the fog, where space and time are shadows on the walls of your mind. The fog lifts. Not all at once. This isn't a stage play, but slowly, like a veil pulled back by curved fingers. And beneath it, you see something strange. Not the grid lines of Newton, not the cool logic of Kant, but a fabric. A stretched, trembling sheet of reality that flexes, ripples, bends. You're in the presence of Einstein now. And space. Space isn't space anymore. It's space-time. You've probably seen the metaphors, the rubber sheet, the bowling ball curving a mattress. And yes, they're useful kind of, but they miss something. The real twist of Einstein's reality isn't just that mass bends space. It's that mass bends time too. And you don't live in space and then move through time. You live in space-time, a four-dimensional blend that flows, tilts, and wobbles depending on who's watching. You want to stand still? Too bad. Everything's moving and not always in the same direction or at the same rate. In Newton's world, gravity was a force, a pull, an invisible hand yanking apples and planets toward one another. In Einstein's world, gravity isn't a force at all, it's geometry. You fall not because you're being pulled, but because the floor beneath you is curving toward mass. Historians still argue whether Einstein ever truly abandoned the idea of force or just reinterpreted it in mathematical disguise. But functionally, it changed everything. You look at the sun, not just as a flaming sphere of hydrogen, but as a well, a divot in spacetime. And Earth, it's not orbiting because it's being yanked. It's rolling, moving in a straight line along a curved surface. And yes, that makes sense if you squint, or if you've had just enough coffee. Let's get strange. Clocks tick slower near massive bodies. Time dilates, not metaphorically, literally. Sit next to a black hole and your minutes become someone else's centuries. GPS satellites account for this time warp constantly. Otherwise, your phone would send you to the wrong Starbucks. This means time is not a universal river, it's a local condition, a flexible coordinate. The shape of reality now depends on who you are and where you are and how fast you're moving. It's not one shape, it's many. A patchwork quilt of individual timelines stitched together with math. You're not floating in space anymore. You're surfing a curved, dynamic fabric. Quirky side note, Einstein came up with special relativity before general relativity, so technically he bent time before he bent space. Special relativity deals with motion at constant speeds. It says that the faster you go, the slower time passes for you, and lengths contract. And simultaneity, that's not a thing anymore. What now for you might be then for someone else. So you've gone from dome to disk to sphere to grid to this. A shape that isn't really a shape but a set of relationships. A geometry that changes based on movement and mass. You can't draw it. You can barely imagine it, but it works. And here's the kicker, light. Light doesn't care about your frame of reference. It always moves at the same speed. That's the rule. No matter how fast you chase it, it stays ahead at exactly the same pace. This messes with time, with length, with causality itself. And Einstein just accepts that. He writes it into the equations. He bends time to make room for light. He bends your expectations of reality's shape until it's no longer intuitive, but it's correct. Now imagine the universe as a trampoline. You drop a bowling ball, say, the sun in the middle. It warps the sheet. You flick a marble, say, Earth, across the surface, and it rolls around the bowl, not because it's pulled, but because its straight path is being deflected. That's gravity now, curved paths in a curved fabric. And when something massive moves, say, two black holes dancing in a violent tango, it sends out ripples, gravitational waves, actual shutters in spacetime, radiating outward at light speed. We detected them for the first time in 2015, 100 years after Einstein said they should exist, because the universe likes to take its time proving a point. Historians still argue how deeply Einstein grasped the full implications of his theory. He resisted the idea of an expanding universe. He didn't love the probabilistic weirdness that came next, but his equations bent the floor, and the floor has never been flat since. This new shape of reality is fluid. It's not that space contains objects, it is the object. Mass and energy tell spacetime how to curve. Spacetime tells mass and energy how to move. It's a feedback loop made of math. You live in that loop. But here's the part that slips into your dreams, this curved spacetime. It's not static, it evolves. It can be stretched, twisted, looped. Wormholes, those theoretical shortcuts through spacetime, fall out of Einstein's equations like an uninvited plot twist. They may not exist, or they may be everywhere, you just haven't seen one. Yet. And black holes, they're not just collapsed stars. They're punctures, places where the geometry goes so deep it folds in on itself. A point of infinite density, a singularity, the end of space, the edge of time. Which means the shape of reality now includes ends, edges, points where the map breaks. You feel very small again, but not insignificant, because Einstein didn't destroy the cosmos, he opened it. He showed you that even space and time, those two most sacred absolutes, are local opinions, not universal facts. The grid is gone, the dome is gone. You float now in a fabric that twists when you lean on it. You're not in space-time. You are space-time. Everything jitters now. You've been falling through curves and diving through fabrics, but suddenly the smoothness breaks. The floor that bent so gently under Einstein, it starts to crackle, tremble, pixelate. Welcome to the quantum world where reality doesn't have a shape so much as a buzz, a fuzz, a nervous tick. And it's your brain's job now to try, futilely, adorably, to make sense of it. You're standing in a lab. There are chalkboards covered in symbols, wires trailing everywhere, and someone in the corner yelling about particles being also waves. You've entered the domain of quantum mechanics, and whatever stability you thought you had, well, it's time to give that up. Nicely, gratefully, maybe with a little nervous laugh. The shape of reality here is indeterminate, and that's not a metaphor. Imagine a particle, an electron, say. You want to know where it is. You think it should have a location, but in the quantum world it doesn't have one until you look, until you measure, until you force it to decide. Before that, it's smeared out like probability jam on toast. This is called the superposition principle. Particles don't have defined properties until observed. They exist in multiple potential states at once. It's only when you look that they collapse into a single outcome. Schrödinger's cat. It's not just dead or alive. It's both, until you open the box. Historians still argue whether quantum mechanics describes the world as it is, or just how we interact with it. Is reality really that fuzzy underneath? Or is it our tools, our clumsy human perception, that can't grasp the truth? Either way, you've just watched certainty implode. And then you meet Heisenberg, who kindly explains his uncertainty principle. It says you can't know both the position and momentum of a particle with perfect accuracy. The more precisely you measure one, the fuzzier the other becomes. It's not a failure of instruments, it's a law of nature. Which means reality doesn't just resist precision, it forbids it. The shape of reality here isn't a sphere or a dome or a grid. It's a wave function, a cloud of possibilities. It only becomes a point when you make it, when you measure. Until then, it's dancing behind a veil. Now take this further. The famous double-slit experiment. Fire particles like electrons at a screen through two slits. If you don't watch, they interfere like waves, rippling, overlapping, forming patterns. But if you observe them, they act like particles, choosing a single path. Observation changes outcome. Looking changes being. You're starting to feel watched, aren't you? This experiment has been repeated with photons, atoms, even molecules big enough to have names. The quantum effect doesn't go away, it just becomes harder to see at large scales. But it's always there, at the core of everything. And here's where things go fully unhinged: the many worlds interpretation. Hugh Everett in the 1950s suggested that every time a quantum decision is made, every time the wave function collapses, reality splits. You choose left, another you chooses right. The cat lives here, the cat dies elsewhere. Every possible outcome branches into a new universe, an infinite bloom of realities. So the shape of reality, it's not just fuzzy, it's branching, like a cosmic fractal. You're not living in the world, you're living in one of the worlds. One path among infinite forks. Quirky tangent. Some researchers propose that these branches can interfere with each other. That occasionally you might catch a shimmer of another universe's shadow. That déjà vu, the Mandela effect, even ghosts, might be brief bleed-throughs from other timelines. Unprovable, of course, but very fun at parties. And if you're wondering where Einstein is during all this, he's grumbling from the corner. He never liked quantum mechanics. God does not play dice, he said, to which Niels Bohr responded, "Stop telling God what to do." Einstein spent years trying to find hidden variables, something to make this chaos feel deterministic again. But the math says no. The weirdness is baked in. So now, you live in a universe where particles teleport, quantum tunneling, entangle across light years, quantum entanglement, and exist in ghostly superpositions that only solidify when you show up and ask questions. Reality in this light isn't something you uncover, it's something you conjure. Not fiction, not magic, just uncertainty as architecture. And then someone mentions quantum foam. The idea that at the smallest possible scale, the Planck length, spacetime itself becomes turbulent. Not smooth, not fabric, but a seething sea of blips, loops, and baby black holes forming and vanishing in trillionths of a second. Historians still argue whether quantum foam is a real feature of the universe or just a placeholder for deeper theory. But if it's real, then even spacetime is not continuous. It's frothy, granular, possibly pixelated. Which leads inevitably to the dream of quantum gravity, the unification of Einstein's curved spacetime with quantum mechanics, the Holy Grail, still unsolved. So for now, you stand in two worlds, one where mass bends spacetime and time slows near stars, one where electrons have no location until you ask politely. The first is smooth, the second is jumpy, and together they don't quite get along. But you do. You live in both, every day. You age slowly if you orbit a black hole. You exist in a probabilistic soup at the atomic level. You can drop your phone, predict its arc, and still accept that its molecules are governed by randomness. You're a Newtonian machine, built from quantum jelly. And the shape of reality. It's a flickering blur of probabilities, an ocean of ifs, a kaleidoscope where looking changes everything. You're twisting now, through folds, loops, and spaces that shouldn't even be spaces. Welcome to topology, the art of shape without edges, where the universe doesn't need to be a sphere or a cube or a fabric or even a fog. It might be a donut, or a coffee cup, or a four-dimensional twist of math that makes your head throb like it's been left in the sun too long. The room around you ripples, not in color but in connection. A table becomes a tube, a cube becomes a torus. You're not hallucinating, you're just in the hands of topologists now. And they care less about measurements and more about how things connect, stretch, and loop. Here's the basic idea. In topology, a donut and a coffee cup are the same thing, seriously, because both have one hole. You can stretch a donut into a cup without tearing it. It's not about geometry, it's about connectivity. And in this game, holes matter more than curves. So when physicists start wondering about the shape of the entire universe, not just its contents, they look to topology. Because space might not just be curved, thanks Einstein. It might be looped, or closed, or finite but unbounded like the surface of a balloon, or weirder. You lie back in imagined space, and the possibilities start to wobble around you. Maybe the universe is a three-dimensional torus, a cosmic donut. Travel far enough in one direction and you could loop back to where you started, arriving behind yourself like a confused ghost. Or maybe it's a Klein bottle, one continuous surface with no inside or outside, impossible to build in real space but not impossible to be. Or a Möbius strip, or a multi-dimensional lattice of interlocking shapes called Calabi, Yau manifolds. Historians still argue whether the actual physical universe has a topology at all, whether shape is even the right word at these scales. But mathematics doesn't mind. It builds them anyway. Quirky fact. In the 1970s, NASA's Cosmic Background Explorer looked for repeating patterns in the microwave background, ripples left over from the Big Bang, that might suggest a looped or finite universe. Nothing conclusive, but some data hinted at edges that might not be edges, a geometry that closes back on itself. And you're not just observing this, you're inside it. So it's not like standing on a sphere and seeing its curvature. You'd have to detect the shape from patterns in light, from echoes in radiation, maybe from seeing multiple images of the same galaxy in different parts of the sky, like reflections in a hall of mirrors. Because if the universe loops, light loops too. You might see the Milky Way behind itself. You think that's a stretch? Not to modern cosmologists. They run simulations, test models, debate whether the universe is flat, open, or closed, each one describing a different geometry, a different destiny. A flat universe expands forever. An open one does the same, just faster. A closed one, it curves back on itself. No edge, no center, just a cosmic Möbius ride. Einstein toyed with this too. He initially believed in a closed, static universe. Then the data said otherwise. Space was expanding. So he changed the equations and called his original assumption his greatest blunder. But topology keeps creeping back, because shape matters, not the kind you draw, but the kind you move through. Imagine a wormhole now. Not just a sci-fi cliché, but a real solution to Einstein's equations. A bridge between two distant regions of spacetime. A tunnel, a shortcut. The math works. The energy requirements are absurd. But if wormholes exist, they change the topology of the universe. They punch holes in it, connect distant patches, make far away meaningless. And if that's true, then the shape of reality is more like a network than a structure. A web of shortcuts and folds, a cosmic hyperlink system, Wikipedia with stars. And then, of course, there's string theory. You tiptoe into that arena and find that reality may have 10 dimensions, or 11, or 26, depending on who's writing the math. Most of them are compactified, curled up so tightly that you can't see or move through them. But they're there, allegedly, shaping the vibrations of fundamental strings. In this view, reality's shape is defined not by the large-scale structure of galaxies, but by the tiny, curled-up dimensions that dictate how particles behave. Like tuning a violin, these dimensions set the tone of the universe. And the Calabi-Yau manifold, that's the shape string theorists love. It's a six-dimensional, folded, squashed thing that looks like someone dropped origami into a black hole. It's beautiful. Useless for decorating your living room, but possibly the shape of the quantum vacuum. You lie there contemplating all these shapes, the donut, the lattice, the loop, the strip, the bubble, and start to realize something. You've been thinking too visually, because the universe doesn't care about what your eyes can handle. It's not built for you, it just is. And its shape, it's not Euclidean, not intuitive, not even really shaped in the way you once understood. It's relational, dynamical, built on connectivity and constraints. You don't live in a dome or a disk anymore. You live in a space that might fold behind you, that might reflect you, that might connect 2 points not by distance but by dimension. So next time you feel lost, just remember, the straight path may not be the shortest one, and where you are might not be where you think you are. Because in this universe, the map folds. You're looking at a screen now, not a star, not a theory, just a glowing surface. And as you stare, something stares back. Pixels, yes, but more than that. Because here's the whisper crawling into your ear. What if the screen is all there is? Welcome to the simulation, friend, or the hologram, or the projected shadow realm of some deeper dimension we can't touch. Whatever flavor you like, tonight's reality isn't curved or flat or looped. It's encoded. The idea that the universe might be a simulation isn't new. It just wasn't always called that. In Plato's cave, remember, people saw only shadows on a wall and mistook them for truth. In Hindu philosophy, the world is Maya, illusion. Not fake exactly, just not the final layer. But in modern physics, we've dressed this idea in math and machine metaphors. Start with the simulation hypothesis. Popularized by philosopher Nick Bostrom, it suggests that if a civilization advances enough to simulate conscious beings, and if they do simulate them, then it's statistically likely we are one of those simulations. You're not the original. You're the copy of a copy, running on someone's cosmic hard drive. Quirky detail. Some physicists are genuinely investigating whether the universe has computational grid artifacts, signs that spacetime might be discrete, not continuous, like pixels. If spacetime has a smallest unit, a Planck length, that's a step toward digitization. Not proof, but a nudge. Still, simulation theory isn't the only show in town. There's another wild idea gaining traction, and it's stranger than code. It's the holographic principle. You're standing now at the edge of a black hole, not too close, just near enough to feel weird about it. And you remember something from earlier. Black holes have surface area. When stuff falls in, the information, the bits that describe what it was, somehow ends up encoded on the event horizon. Not lost, not gone, just projected. This leads to a bonkers conclusion. The information inside a region of space might not be stored in the volume at all. It might be encoded on the boundary. Just like a hologram. Imagine the universe as a sphere. The stuff you experience inside, the stars, the coffee, your oddly persistent thoughts about raccoons, could be projections of data written on the edge. The 3D world emerges from 2D information. Historians still argue whether this principle applies just to black holes or to the entire universe. But string theorists, particularly those working on the AD-SCFT correspondence, don't worry, no quiz. Think it might hold across all of spacetime. The math suggests it. Your common sense disagrees. Your senses scream, but I'm here. I have depth. I have knees. And yet those knees might be a projection from a higher dimensional structure you'll never touch. You don't live in a simulation like a video game. You live in a projection, a rendered experience. The shape of reality is no longer curved, it's encoded, which means it doesn't matter how things look. What matters is how much information they contain. Think about that. Everything you see, feel, remember. It might just be surface-level data rendered into a convincing experience. A perfect illusion maintained by rules you can't rewrite but can occasionally poke at. And yes, it gets weirder. Some quantum gravity researchers propose that space itself might emerge from entanglement. That's right, quantum links between particles might weave together the illusion of distance. If particles are entangled, they behave like they're in the same location, even if they're light years apart. So maybe space isn't a pre-existing container. Maybe it's the result of quantum relationships. You don't move through space, you move through a network of connections. Your position is just a roll in the web. Let that sink in. Not only is space a hologram, it might be a consequence of something deeper. Information, entanglement, relational structure. Which means the shape of reality isn't spatial, it's computational, relational, a language you haven't learned. And yet it feels real. That's the trap. Whether we're simulated, projected, or emerging from entangled math, the experience is sticky, vivid, emotional. You fall in love in a hologram. You stub your toe in a simulation. The pain is real, even if the floor is virtual. Quirky thought experiment. If we are a simulation, would it matter? Could you opt out, file a cosmic ticket, rage quit? Or would you keep going because this is the only game you've ever known? And if we're not a simulation, but our universe still behaves like one at the deepest levels, does the distinction even hold? What's the difference between a world simulating itself and one being simulated? You look at your hand now, 5 fingers, skin, muscle, bone. But under that data, fields, quantum vibrations, maybe even holographic code. You don't feel digital, but then again, your computer doesn't feel binary either. It just is. You might ask, where is this all being projected from? And the answer is both simple and useless, from somewhere else, some deeper layer, one you can't reach. Not yet. The dome is long gone, the celestial spheres have melted, the Newtonian grid dissolved. Even Einstein's curved fabric is just a chapter in this new cosmic abstraction, because now space and time might be illusions. Meaningful ones, yes, but illusions nonetheless. The shape of reality. It's probably not a shape. It's information. Encoded, encrypted, interpreted by minds built to believe in space and time just long enough to survive. And that's the most convincing projection of all. You stop moving. Not because the story has ended, but because time just folded under your feet like a trick floorboard. You're still here, wherever here is, but the ticking that used to march forward like a metronome has slowed, then stopped, then turned sideways. Time, it turns out, may not flow at all. You used to think of time as a river, past upstream, future downstream, and you paddling somewhere in the middle. But tonight, you're stepping out of the current and realizing it might have been a painting all along, a static landscape, a block universe. In this view, all of time exists simultaneously. The past, the future, this very moment, they're not passing, they're placed, like pages in a book. You flip through them one by one and feel motion, but the pages were always there. This isn't just philosophy, it's baked into Einstein's relativity. Remember how time dilates, slows down near gravity, stretches with velocity. That means there's no universal now. Different observers moving at different speeds disagree about what's simultaneous. So which moment is real, all of them or none? Historians still argue whether this view, eternalism, is an ontological truth or just a mathematical artifact, but it messes with your head either way. Imagine a loaf of bread. Each slice is a moment in time. You right now are in one slice, eating cereal, sighing, wondering if your phone is charged. But the slice where you're born, already baked. The slice where you die, also there, you just haven't reached it yet. Not because it doesn't exist, but because you haven't caught up. And that means the shape of reality isn't just bent or curved or pixelated. It's thick. Time has depth. Duration is geometry. You don't move through time. Your consciousness moves through a fixed structure. Your memories, your predictions, your sense of the now, they're just neurological bookmarks in a four-dimensional block. Let's stretch it further. In this view, change is illusion. Motion is perspective. Nothing is becoming, everything just is. You cry not because something is happening, but because some slice of the universe contains a version of you that's crying. That slice always existed. It always will. Feel free to shudder. But not too much, because now you're in the presence of Julian Barber, a theoretical physicist who suggests that time doesn't exist at all. What we think of as motion is just the perception of different nows arranged in a meaningful sequence. Each now is a complete frozen configuration of the universe, what he calls a platonia. And your sense of flow, that's the illusion created by memory. In this model, the universe is a static sculpture made of moments, and your mind just walks through them like a flashlight sweeping across a mural. Quirky side effect: time travel in a block universe isn't about motion, it's about location. The past isn't gone, it's just over there on another slice. The future isn't potential, it's just unseen. You don't need to bend time, you just need to shift perspective. But here's the emotional dilemma. If every moment exists, then so does every pain, every mistake, every joy, eternal, fixed. No undo button, no real moving on. But also no loss. The people you miss, they're still there in their slice. Their laugh, their breath, their favorite food, it still exists. You just can't access it from this frame. Time doesn't heal, it simply holds. And that's both beautiful and cruel. Still, not everyone buys the block. Some physicists argue for a dynamic view of time, something that really does pass. A growing block, where the past and present exist but the future is unwritten. Others suggest time is emergent, not fundamental, something that arises from entanglement or thermodynamics. The arrow of time, the reason why yesterday feels different from tomorrow, may be rooted in entropy. Systems evolve from order to disorder. That's why you remember the past but not the future. That's why eggs break but never unbreak. But even that rule has cracks. At the quantum level, some processes are time reversible. The laws work just as well backward. The arrow is only visible at scale, like a wind that's felt but never seen. You lie back now and the seconds feel thick, pressurized. Every breath you've ever taken still exists somewhere on the loaf. Every version of you, every moment, every thought. They're not gone. They're part of the landscape. And so the shape of reality, it's not a sphere, it's not a donut, it's not a program, it's a block, a crystal, a fixed sculpture of time. It doesn't move, you do. Or at least you think you do. You open your eyes and there's nothing there. Not darkness, not emptiness, just absence. A kind of presence so blank it makes your stomach turn. This, apparently, is what most of the universe looks like. And by most, we mean almost all of it. Because tonight you're chasing shadows. Not metaphors, but real ones, dark matter and dark energy. The twin phantoms of cosmology. You can't see them. You can't touch them. And yet they dominate the structure, evolution, and fate of the universe. Which makes you wonder, what kind of shape is built mostly out of things you can't detect? Let's start with the first ghost, dark matter. In the 1930s, Swiss astrophysicist Fritz Zwicky noticed something odd. Galaxies in the Coma cluster were moving way too fast, like should be flying apart fast, but they were. So he hypothesized there must be some invisible mass, extra gravity, holding everything together. He called it Dunkelmaterei. It didn't catch on immediately, probably because Zwicky had a reputation for being a bit of a cosmic grump. Fast forward to the 1970s. Astronomer Vera Rubin observes that stars on the outer edges of galaxies are orbiting just as fast as stars closer in. That shouldn't happen, not according to Newton or Einstein or basic expectations of orbital mechanics. So what's keeping them from flinging off into intergalactic space? Something invisible, something heavy, something there, but not detectable by light, dark matter. And it's not a small player. Current estimates suggest dark matter makes up about 27% of the universe's total mass energy. Ordinary matter, the stuff you, me, bagels, and black holes are made of, just under 5%. Let that sink in. Almost everything you experience is a rounding error. And yet we only know about this dark matter because of its gravitational fingerprint. It bends light from distant galaxies. It keeps cosmic structures from flying apart. We map it by proxy, like following the movement of trees to detect wind. Historians still argue whether dark matter is made of particles, WIMPs, axions, sterile neutrinos, or if it's simply a sign that our models of gravity break down at large scales. Some fringe physicists propose modified Newtonian dynamics, MOND, which tweaks gravity's behavior in the farthest reaches of space. But the evidence for actual, clumpy dark matter keeps stacking up. Now onto the second ghost, dark energy. In the late 1990s, astronomers measuring the brightness of distant supernovae discovered something even more shocking. The universe's expansion is accelerating, not slowing down under the influence of gravity, not coasting, but speeding up. Like a car that forgot it was supposed to brake at the red light of entropy. What's pushing it, no one knows, so we gave it a name, dark energy. And this time, it's not just a supporting actor, it's the lead. 68% of the universe, a negative pressure field, a kind of anti-gravity, something that doesn't clump, doesn't dilute, and doesn't seem particularly interested in your attempts to understand it. Einstein actually predicted something like this back in the early 20th century. He added a term to his equations, the cosmological constant, to balance out the universe and keep it static. Then Hubble discovered expansion, and Einstein called his constant a blunder. Now, it's back in fashion, a placeholder for whatever dark energy is. So what does all this mean for the shape of reality? It means you've been modeling a sculpture by staring at one shiny corner. The universe you know, stars, galaxies, kittens, carbon, is a whisper in a cathedral made of shadows. Quirky experiment. If you could remove all dark matter and dark energy from the cosmos, it's not clear what would be left. Galaxies might disintegrate. The large-scale web of structure that holds everything in place would collapse. Reality might flatten, or tear, or flicker out like a cheap screensaver. Dark matter shapes the structure of the universe, those vast filaments of galaxies, like a neural network for gods. Dark energy shapes its destiny, pushing it toward coldness, flatness, isolation. You're living in a universe that's growing more lonely by the minute. Galaxies are moving away from us. Eventually, in trillions of years, they'll vanish from view, not because they're gone, but because their light will never reach us again. The cosmos is building its own veil, and you're caught inside it. Even now, physicists are building detectors deep underground, huge vats of xenon or argon buried to avoid cosmic rays, hopping for a dark matter particle to bump into a nucleus. Just once, just a nudge. So far, nothing. Silence. The particles, if they exist, goes through the detectors like thoughts through fog. Dark energy is even worse. We don't even know what to look for. It's not a particle. It's not a field. It's a behavior, a mystery that deepens the more we measure. Some suggest it's tied to vacuum energy, the spontaneous popping of particles in empty space. Others wonder if it's an illusion, a feature of how we measure time and expansion. But whatever it is, it's steering the universe. And you're a brief concentration of ordinary matter, briefly aware, floating through a mostly invisible sea. The shape of reality now. A web woven from things we cannot see, pushed apart by forces we cannot name. And yet here you are. You breathe, you think, you marvel. In a cosmos made of shadow, you shine like a spark. You're inside your own head now, not metaphorically, not spiritually, literally, floating through folds of cortex and bursts of electrical static, wandering a reality so familiar you almost forgot it was a place at all. Welcome to the most personal dimension of all, the shape of thought. Because reality isn't just out there, it's also in here. And if the universe is curved, pixelated, looped, or encrypted, your mind has to interpret that, which means the final shape of reality for you depends heavily on what's going on behind your eyes. So let's walk through your gray matter, shall we? First stop your visual cortex. You don't see reality, you construct it. Light hits your eyes, gets flipped, filtered, downsampled, interpreted, and only then turned into something you call seeing. But that's not raw truth, that's interface. Your brain paints over the edges, fills in the gaps, corrects shadows, and smooths what's too weird to understand. You've never truly seen what's there, only what's useful. Second stop, language. That handy word machine in your skull doesn't just describe reality, it defines it. Try explaining the color blue to someone who's never seen it, or the idea of before to someone without a time sense. You'll find that reality's shape is deeply tangled with what you can name. Some linguists propose linguistic relativity, the idea that the structure of your language influences how you perceive space, time, even causality. In some cultures, people don't say left or right. They use cardinal directions. The cup is southeast of the plate, which means they always know where north is. Their spatial reality is rotated 90 degrees from yours. Historians still argue whether language truly shapes thought or merely reflects it, but the overlap is undeniable. The words you inherit are the gridlines of your mental map. If your vocabulary lacks a concept, your world lacks that texture. Now consider memory. You don't store perfect recordings. You store fragments stitched together by emotion and narrative. Every time you remember, you're editing, and every edit changes the memory. That means your past isn't fixed, it's revised, recolored. You live inside a mental world that reshapes itself based on what matters to you now. So how stable is reality when the past itself is a reconstruction? And then there's a tension. Reality as you experience it is mostly what you notice. You're blind to most of your visual field, deaf to sounds outside your focus, numb to your own heartbeat unless you try to feel it. The world is infinite, your mind is finite, so it slices, ignores, compresses. You are not a camera, you're a highlight reel. Which leads to a deeper truth. Your consciousness is a bottleneck, a filtering system. Most of your brain's processing happens below the level of awareness. Decisions are made before you're aware of them. Your self gets the memo afterward. So what is your self exactly? Some theories describe it as a narrative illusion, a story your brain tells to keep track of its own decisions. Others suggest it's an emergent pattern, a feedback loop between memory, attention, emotion, and perception. Whatever it is, it feels like a stable center, a you, but neurologically, it's more like a shifting committee that votes on what's real, what matters, and what's true. Quirky fact, in split-brain patients, those whose corpus callosum has been severed, each hemisphere can hold different beliefs, preferences, even make separate decisions. That means your sense of being one person is held together by a literal bridge. Cut the bridge and reality splits inside you. Which makes you wonder, is the universe fragmented or just your mind? And here where it gets extra strange. What happens when minds meet? When one subjective world brushes up against another. You learn that reality is also social, shared, a collaborative hallucination. If everyone around you believes the earth is flat, or time is circular, or that cats hold divine power, your brain will start adjusting. Not because it's wrong, but because it's adaptive. Your perception of reality isn't just shaped by neurons. It's shaped by culture, context, language, memory, bias, trauma, and the weird rules of your tribe. No one sees the raw world. They see a version that's been filtered through community. That's why consciousness studies, this bizarre academic melting pot of neuroscience, philosophy, and quantum mysticism, can't agree on anything. Is consciousness a byproduct of brain chemistry, a fundamental property of the universe, a simulation glitch, or an illusion we're all hypnotized by? Historians still argue fiercely about where consciousness lives, or even whether it needs to live anywhere at all. Some believe it's local, trapped in your brain. Others suggest it's distributed, a cloud, a field, a network that minds tap into like Wi-Fi. Whatever the case, you now have to consider a chilling possibility. The shape of reality isn't just outside, it's inside, and your inside might be unreliable. You think you know who you are, but who you are thinks that too. So what does that make you? In the end, maybe the shape of reality isn't something you find, or measure, or simulate. Maybe it's something you compose, moment by moment, with the tools you didn't know you were using. Thought, language, memory, belief. Reality, it turns out, might be neuroplastic, molded by your experiences, customized to your limits, personal. Not objective, not shared, not fixed, but vividly, seductively yours. You're not alone anymore. You tilt your head, blink slowly, and realize your version of reality isn't universal, not even close, because all around you, other eyes are watching the same world and seeing something else entirely. Welcome to the animal kingdom's fractured mirror, a realm where every species crafts its own bespoke version of real. You human have a very particular reality, colors, depth, sound, texture, language. You rely heavily on sight. You expect continuity. You name things, categorize them, and assume you're perceiving the world as it is. But now imagine being a bee. You step into its mind, and the first thing that hits you is ultraviolet. You see patterns on flowers invisible to humans, landing strips glowing like neon signs. You navigate by polarized light. Your vision isn't better than a human's. It's tuned differently, because bees don't need to read road signs. They need to find nectar fast. Next, slide into the world of the bat. Sight shrinks, sound explodes. You're navigating by sonar, now echolocation. Each squeak bounces off walls, trees, insects. Reality becomes a staccato map of returning echoes. Distance becomes delay. Shape becomes pitch. You don't see objects, you hear their outlines. Historians still argue whether bats construct internal pictures from these echoes or exist in a more abstract sonic space. But one thing's clear: they don't experience your version of up or down. Their universe is built on timbre and bounce. Now try on the mind of a dog. Smell becomes the dominant force. You're tracking chemical trails with exquisite precision. Each footstep, each mood, each meal leaves a cloud. To a dog, time smells. Emotions smell. History lingers in corners and along sidewalks. You can detect a scent trail's direction. You don't see the world, you inhale it. Your dog doesn't just know someone was at the door. It knows who, when, what they had for lunch, and how anxious they felt, all from a sniff. That's not a trick, that's their world model. And now we take a leap, a shimmering, wild, unsettling leap, into the mind of the mantis shrimp. Yes, the meme-worthy creature with 16 types of color receptors. You have 3. Scientists once assumed it could see colors we couldn't imagine, but more recent studies suggest it might not mix those colors like we do. It may not see more hues, it may just sort light more efficiently. But the real shocker, it can detect polarized light in multiple directions, like sunglasses for quantum spies. The mantis shrimp punches so hard it can break aquarium glass. But even more impressive is how alien its sensory reality must be. Imagine seeing not just color, but angle, polarity, frequency, all layered over a vision system humans can't begin to parse. Quirky twist: some birds, like the European robin, may be able to see magnetic fields, not feel, see. Researchers believe their retinas contain molecules affected by Earth's magnetic field, letting them perceive a directional haze overlaying their vision. Their GPS is built into their eyes. That's right, some animals look at the world and see north. You're starting to get it now, aren't you? The shape of reality depends entirely on how you access it. Your nervous system isn't a passive receiver, it's a sculptor. It throws out most of the incoming data and amplifies what keeps you alive. It builds a user interface, not a truth. You might see an apple. A bee sees ultraviolet petals nearby. A dog smells the hand that picked it up. A bat hears the roundness of the fruit. All of them are right. All of them are wrong. They're not touching reality itself. They're touching their slice of it, their Umwelt, a German term meaning surrounding world, but in this context, it means the individual perceptual world of a species. Each creature exists in its own bubble of sensed reality. You thought the universe had one shape. It has billions, one per species, possibly one per individual. Even within humans, there's variation. People with synesthesia might taste sounds or see colors when they hear music. People on the autism spectrum might experience sensory input with painful intensity. Some forms of face blindness erase the ability to recognize others. Each brain tweaks the filter slightly. Even your mood alters your reality. When you're anxious, your visual cortex sharpens contrast. You literally see the world as more threatening. When you're tired, your reaction time slows and even time feels thicker. Your inner state shapes your outer world. So what does this mean for reality? It means there is no single, stable real. There is no master shape. There are only interpretations, constructed and reconstructed by millions of wet, wrinkled processors crawling across the earth. The philosopher Thomas Nagel once asked, "What is it like to be a bat?" The answer, most agree, is inaccessible. You can't imagine it. Your brain has no template. You're locked in your own species-specific hallucination. Everyone is. Even plants. Yes, plants sense the world in alien ways. They detect light angles, moisture gradients, chemical signals. They remember stress. They may not have neurons, but they respond to music, touch, and damage with behavior that, while not conscious, is reactive. Historians still argue whether consciousness is required for perception. But even perception without self-awareness builds a world, shapes it, and in shaping it, creates a unique experience of reality. So the question isn't just, what is reality? It's whose reality? And you're not seeing the world. You're seeing a version of the world built to keep your particular species upright, social, and safe from cliffs. It's good at that, but it's not exhaustive. Reality, it turns out, is a zoo, a chorus, a mosaic of incompatible truths, and you're just one voice in the chorus, one color in the kaleidoscope. You're not yourself anymore. You've stepped out of your standard issue brain and wandered into something squishier, loopier, far less linear. Welcome to altered states, the shadowy backdoors into alternate versions of reality. This is the zone of mushrooms, meditation, and misperception, where shape doesn't just change, it dissolves, shatters, reassembles in forms your waking mind can't handle. You're lying in a dark room now. The ceiling ripples, the floor breathes, your body disappears by degrees. This isn't a dream, this is something else. You've taken psilocybin, or ayahuasca, or ketamine, or maybe nothing at all. Maybe you've just stared at a wall for 20 years like a Zen monk until your ego gave up and left you to float in the great in-between. And suddenly the shape of reality. Not a grid, not a sphere, not even a loop. It's a feeling. Let's start with the psychonauts, the scientists, therapists, and chemically adventurous artists who have explored consciousness by chemically shifting it. Take Albert Hofmann, who synthesized LSD and famously took a trippy bike ride home, or the Mazatic curanderas of Mexico who used psilocybin mushrooms in sacred rituals long before scientists gave them Latin names. What do they describe? Melting boundaries, dissolution of self, a sense that time has stopped or ceased to exist altogether, a sudden, overwhelming oneness with everything, the walls, the wind, the very idea of wind. Sometimes it's euphoric, sometimes terrifying, sometimes both. Historians still argue whether these states provide access to some deeper truth or just mess with the brain's filters. Are you lifting the veil or simply ripping apart your model of reality and watching the pieces float? Stanislav Grof, a pioneer in psychedelic therapy, described these states as non-ordinary states of consciousness, capable of producing profound psychological insight. Others liken them to neurological chaos, synesthesia, pattern overload, a funhouse mirror in your mind. Either way, they change your model of the world. Try this. Under the influence of psilocybin, the brain's default mode network, the part responsible for your sense of self and time, goes quiet. Meanwhile, far-flung brain regions that normally don't talk, they start screaming at each other. The result? A new, strange, highly interconnected version of reality where the boundaries between subject and object collapse. You're not in the room anymore. You are the room. And the walls have opinions. Now leave the chemicals behind. Sit down, breathe again and again for a week, a month, a year. Monks who engage in long-term meditation, particularly Vipassana or Dzogchen practices, often report similar states: ego dissolution, timelessness, radiant awareness, a felt sense that the self is an illusion and that awareness is fundamental. They don't need drugs, they use stillness. And yet the result is the same: reality warps, or rather the filters of perception fall away. The mind stops narrating, stops dividing, and without those divisions, the world stops being out there. Some Buddhists describe this as emptiness, not nothingness, but the absence of inherent separation. All things arise interdependently. Shapes exist because of context, not substance. Which means no fixed shape, just relationship, flow, pattern. Quirky historical tidbit. In the 17th century, philosopher and mathematician Blaise Pascal had a mystical experience so intense he sewed a written account into his coat and carried it for years. It wasn't a drug trip. It was a moment. Fire, God of Abraham, God of Isaac, God of Jacob, not of the philosophers and scholars. Reality had tilted for him, and it never went back. These altered states are not always sublime. Sometimes they're horrifying. A bad trip can feel like eternity trapped in a washing machine made of your own regrets, sensory distortions, paranoia, the fear that time has stopped, that you've lost your mind forever. But even then, it's not unreal. It's just a different model, and once experienced, it becomes part of your library. You can't unsee it. Back to neuroscience. Some researchers propose that the normal brain works like a predictive machine. It builds models of what's supposed to happen next and uses sensory input to correct those models. Psychedelics may weaken this prediction engine, allowing sensory input to flood in unfiltered. The result? A new model of reality that's more chaotic but potentially more honest. Historians still argue whether that's clarity or confusion. Is a hallucination false because it's unique? Or is all perception hallucinatory, just more consistent? Let's step into another kind of altered state, sensory deprivation. Float tanks, silence chambers, darkness retreats. Deprive your brain of input and it starts inventing its own. Patterns emerge, time becomes mushy. Your body disappears. You may even feel a presence in the room that isn't there. The brain abhors a vacuum. It fills the silence with itself. Reality without input becomes free jazz. Then there's near-death experiences, the bright tunnel, the life review, the sense of leaving your body. These aren't universal, but they're common across cultures. Some researchers think they're just oxygen-starved brains firing nonsense. Others think they hint at something deeper, an inherent shape to the threshold between life and whatever comes after. Either way, the experience is convincing. And that's the key. In all these altered states, drug-induced, meditative, traumatic, the person insists what they felt was more real than waking life. Not less, more. The shapes were cleaner, the truths were clearer, the boundaries were gone, and somehow it all made sense. You come back changed. Not because you saw the face of God, but because your model of reality, your default, day-to-day simulation, was shown to be just one of many. The dome cracked, the grid vanished, the self dissolved. And now you live with that knowledge. Reality might be stable, but your perception of it, always up for negotiation. You're back in the lecture hall now. It's late, the chalk squeaks, the coffee's cold, and no one in this room can agree on anything. Physicists, philosophers, cosmologists, logicians, each packing, scribbling, waving their arms as if to swat the truth out of midair. This is not a TED Talk. This is a trench war. Welcome to the part of the journey where scholars still argue about everything. You thought science would bring closure. Cute. You thought philosophy might settle the bigger questions. Adorable. Instead, you find a centuries-long shouting match in which nothing, not even math, is sacred. Let's start simple. Is mathematics discovered or invented? One camp says math exists independently of us, floating in some perfect, abstract Platonic realm. Circles, numbers, primes, they're eternal truths we stumble upon like cosmic fossils. The other camp says no, math is a human creation, a language, a model, useful, sure, but not divine. The square root of -1 isn't hiding under a rock, it's something we made up to solve problems. Historians still argue about this, fiercely. Entire academic careers have bloomed and withered on this question alone, and neither side is ready to back down. Now let's ramp it up. Is time fundamental, or is it emergent, something that only arises when enough particles get together and start dancing? You walk into one camp and hear that time is basic, woven into the fabric of spacetime itself, Without time, change can't happen. Physics can't function. Entropy loses meaning. Reality stalls. Then you wander into the rival tent, where time is a byproduct of entanglement, or maybe thermodynamics, or maybe consciousness. The universe doesn't flow, you just think it does. Time is a hallucination that evolution found useful. There's even a theory, timeless physics, that suggests the universe is just a big static block of all possibilities. No change, no flow, just frozen configurations. And you're the movement between snapshots, a flipbook that thinks it's a movie. Let's not forget quantum mechanics, which remains the undisputed champion of scholarly infighting. We've got the Copenhagen interpretation, wave functions collapse when measured. The many worlds interpretation, they don't collapse, they just split. The de Broglie, Bohm pilot wave theory, particles are guided by hidden variables. And objective collapse models, maybe wave functions just implode on their own sometimes. And none of these interpretations give different predictions. That's right, they all agree on what happens, but not why. You're using quantum mechanics every time you use a laser, GPS, or smartphone, but no one can tell you what's actually going on beneath the math. It's like flying a plane powered by riddles. Quirky fact, Einstein hated quantum indeterminacy so much, he once spent years corresponding with Niels Bohr trying to find loopholes. Bohr, unfazed, replied with increasingly Zen-like counterarguments. In the end, Einstein couldn't shake the sense that God does not play dice. Bohr's reply, "Stop telling God what to do." Now consider the concept of a law of nature. You probably imagine physical laws as fixed, eternal truths, like commandments etched in cosmic stone. But some philosophers argue that laws might just be descriptions, habits of the universe, not mandates, regularities, not rules. What if gravity isn't a law, but just something that keeps happening? And what if those regularities change? Even the idea of cause and effect, the sacred spine of science, is under siege. Quantum entanglement challenges the very notion of local causality. Bell's theorem shows us that either the universe allows for faster-than-light information, or it doesn't care about causes at all. Scholars still argue whether this means we should abandon cause as a foundational idea, or simply accept that the universe is spookier than our metaphors can manage. And speaking of spooky, are we alone? The Fermi paradox asks, if the universe is so big and life should be so common, where is everybody? Some say we're early, others say we're boring. Others believe intelligent life self-destructs before it can build spacefaring civilizations. And a few insist that the aliens are already here, quietly watching and laughing at our chalkboards. But no answer satisfies all the data. No resolution ends the fight. Because this isn't about answers. It's about models. Everyone has one, and none of them match up exactly. Even in cosmology, the supposed pinnacle of scientific agreement, there are bitter debates. Is the universe flat or curved? Finite or infinite? Did it begin with a bang, or was that bang just a bounce from a previous cycle? Some physicists toy with cyclical universes, where time loops and resets. Others think we came from a quantum fluctuation in a vacuum. Others believe the universe has always existed, just changing form. And then there's the anthropic principle, which argues that the universe must be compatible with life, because otherwise we wouldn't be here to notice it. Some see that as profound. Others call it a cosmic shoulder shrug. Even in consciousness studies, the arguments get feral. Is consciousness a physical process, an emergent phenomenon, a fundamental feature of the universe like mass or charge? Are we meat computers? Or something more? You listen to philosophers cite Descartes, Dennett, Chalmers. You hear words like qualia, panpsychism, integrated information theory. And after an hour, your brain begins to weep gently into its own folds. Because for every model, there's a countermodel. For every theory, a paradox. For every answer, a footnote that eats the answer alive. So what does this tell you about the shape of reality? It tells you it's not a circle, not a grid, not a string. It's a debate. A living, mutating, never-finished process of minds, trying to map something far too large with tools far too small. And maybe that's the point. Reality doesn't have a single shape. It has an argument, and you're part of it. You step back now, way back, past the chalkboard debates, past the theories and thermodynamics, past even the language that once helped you pin down the world. You zoom out until you're barely a dot on a dot orbiting a dot, and suddenly everything shifts. Because now you see it. The universe isn't something you're inside. It's something that's inside you too. Tonight, you're witnessing the strangest shape of all, a universe that knows itself. Somewhere between the carbon in your cells and the heat in your thoughts, reality has become reflexive. A loop, a feedback system so complex, so recursive, it's dizzying. You are the cosmos, looking at the cosmos, asking what the cosmos is. You are a self-aware pocket of stardust, briefly conscious, briefly curious, with just enough neurons to wonder what neurons are. And that changes everything. Because up until now, we've treated you like an observer, a thinker maybe, a measuring stick with opinions. But in this section, you're not on the sidelines, you are the process, you're part of the shape. Let's break that down. Your atoms were forged in stars. That's not poetry, it's nuclear astrophysics. The calcium in your bones, the iron in your blood, the oxygen in your lungs, they were born in supernovae. Explosions that tore across ancient galaxies, long before Earth was anything more than a smudge in the timeline. Quirky fact, when Carl Sagan said we are star stuff, he wasn't being poetic. He was being literal. Every heavy element in your body was made in the death throes of ancient stars. You're not just part of the universe. You're made from its memories. And yet you think, you reflect. You look up at the stars and the stars through you look back. That's the loop. That's the shift. In this model, reality isn't just a structure, it's a process. One that folds in on itself, not a straight line, not a spiral, a strange loop as Douglas Hofstadter once called it. A pattern that refers to itself. Consciousness emerges, perhaps inevitably, from complexity. Neurons talk, patterns form, thoughts arise, and one day you realize you're aware of being aware. You're not just processing the world, you're constructing a model of yourself in the world, and then wondering whether the model is accurate, and then questioning the questioning. You're standing in a hall of mirrors with no exit, and that's what makes you human. Historians still argue whether consciousness is a computational accident or a fundamental aspect of the universe. Some physicists flirt with the idea that awareness might be as basic as space and time. Others scoff. But the fact remains, here you are, wondering what here means. Which means the shape of reality has grown a face, yours. You might imagine this feedback loop as a torus. A donut again, yes. But this time the loop isn't physical, it's logical. Information goes out, perception happens. Information comes back. You interpret, reflect, adjust, rinse, repeat. And in that repetition, reality gains awareness. This idea isn't new. In Hindu cosmology, Brahman dreams the universe, and you are part of the dream dreaming back. In the West, thinkers like Spinoza and Whitehead hinted at a universe where mind and matter were not separate, but woven together. Modern science echoes it, sometimes awkwardly. In quantum mechanics, the observer changes the observed. In evolutionary biology, consciousness confers survival. In AI research, machines are starting to reflect back our questions, sometimes too well. You begin to see, reality's shape might be recursive. It builds complexity, which builds awareness, which reflects on complexity, which builds more awareness. The snake eats its tail. Ouroboros. The thing sees itself. Even your brain is built this way. The thalamus filters incoming sensory information and the prefrontal cortex processes it. But there's a loop, a constant feedback between action and perception. You move, you feel the result, you update. Every moment is a test, every breath a hypothesis. And in that feedback, reality gets smarter. You've seen this at the collective level too. Civilization is a meta-brain. Millions of minds building tools, writing books, making mistakes, correcting them. Each generation building on the last. Science, art, philosophy, they're not final answers. They're refined questions, better approximations of a truth too big to name. So what's the implication? If the universe is capable of generating consciousness, and that consciousness is capable of understanding the universe, then maybe understanding is the function. Maybe the point of all this isn't to survive or expand or conquer. Maybe it's just to reflect, to look, to know. And if that's true, then the shape of reality isn't geometric, it's epistemic. It's about knowing, not as a noun, as a verb. Knowing as being. Now take one more step back. You imagine the edge of the universe, not as a wall, but as the limit of questions we're able to ask. The final boundary isn't out there, it's inside us. When our questions run out, so does the map. The unknown isn't a location, it's the absence of curiosity. And right now, you're curious. You, a thinking patch of matter, are reaching out to understand the totality of which you're a part. And that's not a metaphor. That's the shape. A curve folding into itself, a system aware of itself, a universe whose particles once scattered blindly through space, and now somehow ask why. You're falling now, but gently. Not through space, not through time, through understanding. And somewhere in the slow descent, a question drifts down beside you like a feather. What if reality isn't a shape at all? You catch it, hold it, turn it over in your hand. All this time you've tried to give reality form: domes, trees, spheres, clocks, foams, fabrics, code, blocks. Something to grasp, something to point at and say, there, that's what everything is. But now, at the end of this long, winding, brain-melting journey, something quiet creeps in. Maybe all these metaphors weren't describing reality. Maybe they were describing you. Let's step back. You've seen reality as a dome above ancient fields, as a tree with divine roots and branches, as a stack of turtles of all things, as a mathematical clock, a fog, a fabric, a probabilistic wave, a hologram, a hallucination, a heated debate, a mirror. Each version came with its own rules, its own limitations, its own beauty. And each time you adjusted, not because reality changed, but because your tools for understanding it evolved. That's the quiet truth humming behind all 20 of these sections. The shape of reality isn't fixed. It morphs depending on your questions, your senses, your needs. When you were trying to stay alive, reality was a sky with gods and monsters. When you needed precision, it became a geometry. When you sought certainty, it became equations. And when you searched for meaning, it looked back at you like a strange mirror. So maybe the shape of reality is not a structure, not a substance. Maybe it's a relationship, a shifting dance between the world and the models you use to survive it. And yes, this might feel unsatisfying. You wanted a final answer, a crisp diagram, a shape you could tattoo on your forearm, but maybe the absence of finality is the answer. Because in the end, every map is provisional. Every model is wrong, but some are useful. And the ones that last aren't the ones that claim to be reality, but the ones humble enough to say, this is what reality looks like from here. Historians still argue, loudly, lovingly, endlessly, about which model is best. Physicists revise equations. Philosophers invent new categories. Spiritual teachers draw mandalas in the sand and erase them with the wind. And all of them, in their own way, are right. Because none of them are trying to show you what reality is. They're trying to show you how to move through it. And maybe that's enough. So where does that leave you? Right here, in your own Umwelt, your own filtered, flawed, phenomenal version of everything. And that's not a failure. It's the point. You're a living interface, a mind projecting maps onto terrain it can never fully see, and as long as you're alive, that projection will keep shifting, evolving, glitching, growing. Maybe the dome becomes a web. The web becomes a waveform. The waveform becomes a story. The story becomes you. Quirky thought to end on. If you zoom far enough out from all the models, all the shapes, all the diagrams, you start to see a new pattern emerge, you looking for patterns. That's the most consistent thing across history. Not the dome, not the loop, not the math. The desire to explain, to connect dots, to assign shape. And in that need, for order, for understanding, for a geometry that means something, you give reality a shape. Not because it has one, but because you do. And maybe, just maybe, that's what reality has been all along. Not a dome or a donut or a dance of particles, but a question, and you reaching. Now take a breath. Let the models dissolve. Let the shapes uncoil. Let the ceiling above you go soft and the floor beneath you feel just a little less solid. You've been chasing the contours of everything, space, time, thought, truth, and now it's time to let them fade. You don't need to hold all of this. You never could. The dome, the grid, the fabric, the feedback loop, they were tools, not cages. Versions of the same infinite whisper, refracted through different minds in different ages with different needs. And tonight your need is simple, stillness. So let your thoughts drift without direction. Let the questions that once buzzed in your mind sink like silt. Let the contradictions rest. Reality will still be here when you wake up, weird and unfinished, whispering its riddles. Maybe you'll dream of crystalline spheres, or floating clocks, or giant turtles chewing on space-time, or maybe nothing at all. That's fine too. The universe doesn't need your attention to keep spinning. And your brain, it's earned the right to shut down the inquiry engine for a while. So wherever you are, in a city that never sleeps, a quiet town, a distant farm, or a tiny room with too many books, you're part of something big. Not because you understand it, but because you wonder. And that, more than anything, gives the universe its shape. Good night.